Good evening. As you can see, I'm talking to you not from a BBC studio, but from my observatory down at Selsey in Sussex. And it's from this dome, with this telescope, that I've spent a lot of time in the last few months looking at the planet Mars. Now, I know we've dealt with Mars several times in recent Sky at Night programmes, but I don't apologise for coming back to it now, because we're getting this fantastic new information through from the American probe Mariner 9, which is going round and round the planet, and it really is altering all our ideas about Mars. Last summer, Mars was as close to us as it can ever get, a mere 35 million miles, and it was very bright. It was also, unfortunately, very far south in the sky, and so it was low down. And from here, to see it, you had to turn your telescope almost onto the horizon, like that, which of course meant that you were looking at Mars through a very dense layer of the Earth's atmosphere, which did the definition no good at all. And to complicate matters still further, from October onwards, Mars experienced one of its major dust storms that it does get every now and then, and for a time there was so much dust in the Martian atmosphere that you simply couldn't see the surface features at all clearly. And that was the case when the Russian and the American rockets got there toward the end of the year. Now, the dust storm has cleared away, and Mars is a great deal higher up. And in fact, when darkness falls tonight, you will see Mars, right up there, in the constellation of Taurus, the bull, not very far away from Aldebaran, and not quite so bright. Because Mars is now a very long way away from us, and even with telescopes like this, or even larger ones, you can't see very much. These photographs, though, coming back from Mariner 9, really are quite staggering, and they make us have very new ideas about what Mars is like. We can't be certain now that Mars is lifeless, and neither can we be sure that it is inert, because there may well be active volcanoes there, and this is an entirely new kind of departure. From Earth, I'm afraid we're not going to see Mars well again until the middle of next year. And so, for the moment, there's not really a lot of point in looking at Mars through telescopes like this. What we've got to do is to try and interpret the results coming back from Mariner 9. And so let's now go into my study and have a close look at what we've been learning. Obviously, the geography of Mars isn't as familiar as that of the Earth, or the Moon for that matter. So I think the very first thing we ought to do is to find out exactly where we are. And these are some of the drawings that I made with that telescope you've just seen in September, before the dust cloud started, and when the dark markings were nicely on view. And that one is called the Syrtis Major. Anyone who's observed Mars knows that one. It's the most prominent of all the dark features, and you can't really mistake it under good conditions. And whether it's due to some kind of vegetation, or whether it's not, well, that's anybody's guess. Certainly we used to believe that it is, now we're not so sure. Well, in September, all was well. And then, in October, the dust storm started. And you can see that these drawings don't show very much. Well, that wasn't my fault, and it wasn't the fault of the telescope. It was the fault of Mars, because the atmosphere was so laden with dust that we simply couldn't see through it. It was the top of a kind of impenetrable bank of dust, and that lasted for some time. And then in December, we started to see the dark markings again, because the dust storm cleared away, as you can see here. But of course, by that time, Mars had receded from the Earth, and the disk had become very small, so you couldn't see very much anyway. It was just awkward. Now, here, I've got a little globe of Mars. It was made in 1877 by a gentleman named Neaston, and he was a very famous Mars observer of his day. And he also showed the dark markings. There again is the Syrtis Major, which used to be called the Hourglass Sea, which is rather a nicer name, I think. And over here we have another one, just above the Martian equator, called the Mare Serenum. And I want to say more about that later on, because we now have got some fantastic close-range pictures of areas in the Mare Serenum. I say it just above the Martian equator, because on my drawings, and in this globe, we've got south at the top, because that's the way the observational astronomer, such as myself, actually sees them, because telescopes do turn things upside down. But the American space authorities don't do it that way. They print all their maps and drawings and photographs and charts with north at the top. And so for the rest of this program, we'll go along with that, and we'll put north at the top. And I've got here one of the more recent NASA Mars maps. It's a pretty modern one. It includes the results of the Mariners of 1969, numbers 6 and 7. Obviously not Mariner 9, because there hasn't been time yet. But you can see the features clearly. There is the Syrtis Major, and it's heavily cratered. We knew that already. Over here, not far from the area we know as Electris, there is the point where Russia's Mars 3 soft lander came down. But of course, we didn't learn very much from that, because it ceased transmitting after only 20 seconds. Over here, we have the Mare Serenum again, and in this area, there, we have a very interesting feature called the Nix Olympica. Well, I've seen that quite often, only of course, to me, with my telescope, it looks like a tiny dark patch. And we now know from the mariners that it is, in fact, a crater, and a very interesting one, too. I'll show you some photographs of it in a minute. The poles of Mars are covered with a whitish deposit, formerly thought to be ice or snow or something like that, then possibly put down to solid carbon dioxide, and now we think it may be a mixture. Anyway, these polar caps are very prominent, and they do change with the Martian seasons, because they are large in Martian winter, and then as spring and summer comes on and the temperature rises, so the polar caps shrink. This is the area of the South Pole, and we have in fact got some particularly good pictures of features near the South Polar region, and these were taken by Mariner 9. And I think really the Martian South Pole is a pretty good place to begin showing you this sequence of incredible photographs. And JPL have very kindly sent us through quite a stack of them. So here, first of all, is the actual South Polar area. You can see there that layer of what we can call frost. Although, oddly enough, when that particular picture was taken, the polar point itself wasn't covered, because the geographical pole and the centre of the polar snow aren't coincident, and we've known that for some time. And here's another picture of the South Polar area, taken from a distance of 2,500 miles, and that covers about 50 by 62 miles. And as you can see, there are all kinds of interesting features there. And really, we are not quite certain what they are, and the whole geology of this South Polar area is at the moment a bit uncertain. So let's turn to something about which we are rather more confident, the rather obvious volcanic structures. And I'd like to begin with the one I mentioned earlier, the Nix Olympica. And here it is. Very interesting indeed. You can see there the crater-like structure, and you can see that it's got rather scalloped edges, and it is rather obviously a volcanic caldera. And one very interesting point about that, as seen from Earth, it's very often covered by cloud, and I'll come back to that a bit later on. Here's another view of the Nix Olympica, and you can see there a very considerable amount of detail, and it looks very much like a volcano of the Hawaiian type, only the base is about 300 miles wide, which means that it's even bigger than Hawaii. So Mars does seem to have been a world where volcanism has played a very, very important part. And here's a closer-up view of part of the Nix Olympica, kind of feathery structures there, and there were steep cliffs, and things seem to have more or less flowed downhill. Now, not very far away from Nix Olympica, we have another thing, which is known as Middle Spot, and like Nix Olympica, it's high. And there it is, and this is quite obviously a shield volcano, and that was taken from a distance of about 1,200 miles from Mars. And you can see there that the walls are scarred, where loose material seems to have flowed down the steep cliffs, and in parts it's been scoured, presumably because the Martian winds have simply blown the dust away. And even though Mars has got a very thin atmosphere, the winds are quite quick, even though, of course, they haven't got a great deal of force. Now, here we have another caldera in the Pavernis Lacus, and that one's quite big. It's 43 miles across, and you can see it has the usual kind of obvious volcanic structure. And another one is near the area which we know as Ascrius Lucas, in the continent of Tharsis. And this was a photograph taken fairly early on in the Mariner series, when the dust storm was still there. And this thing, like Nix Olympica, appears to be poking out at the top of the dust. And this indicates that it's high. And in fact, we now know that quite a number of these crater complexes are elevated, several miles above the mean surface. And if that were not enough, well, just have a look at this one, in what we call the Nodus Gordii. And there we have a very obvious caldera, again high up, and just look at those concentric fractures along the limb. It's difficult to imagine any landscape more obviously volcanic than that. And these are very strange craters in the area of Phaefontis, incidentally not very far away from where the Russian soft lander came down and transmitted for 20 seconds. And the interesting thing to me about those craters is that those dark areas on the floor. Now, those dark areas don't seem to be atmospheric. They really are features of the surface, and they're a bit like some of the dark-floored craters on the moon, and I think we can interpret those quite easily as lava lakes. Now, I've shown you several of these pictures, and one thing you will notice, all the crater walls appear to be pretty sharp. Now, this is fascinating. On the moon, you get the craters which are also pretty sharp, and there are some typical moon craters, but this you would expect, because on the moon there is no atmosphere, and therefore there's no wind erosion. But on Mars, there is. There is atmosphere, and there is dust being blown around, and you're going to get erosion. And that means that over comparatively short periods on geological timescales, your craters are going to be worn down and smoothed. But on Mars, they aren't. So what's the answer? And the only answer I can see is that these formations on Mars are geologically recent. And by the standards of the moon, they haven't been there for very long. That means that volcanoes have been active on Mars into the recent past, and they could even be active now. Do you remember a few minutes ago, I talked about the Nix Olympica, which we know is a high area and a crater complex, and I said that very often over that area you get clouds. Now, these clouds could be due to one of two causes. They could possibly be due to ordinary condensation, just as you get over high areas on the Earth. But it's equally possible, in my view, that these clouds could be due to material being sent out from active volcanic vents in the Nix Olympica. And if that is so, then it means that Mars, even today, is a living world and not a dead one like the moon, at least so far as volcanic processes are concerned. Well, from rather obvious volcanoes, let's turn to things which are rather more mysterious. Here's an irregular, jumbled area near the area we call Juvente Fons, and you can see there evidences of landslides. And here's one much closer to the South Pole, only about 500 miles away. And those curious structures near the top are about 10 miles in diameter. Now, they don't seem to be of the same kind as the others. They must be of rather different origin. And because they are not so very far from the pole, it's been suggested they might be due to polar processes or something of that nature. Possibly due to the melting of ice on the ground, whether ordinary ice or solid carbon dioxide, we don't know. Well, that's only a theory at the moment. It just could be true. And here's another one in the Lacus Phoenicis. And this time the entire area is dominated by these grooves, which is very interesting indeed, because each one of those grooves appears to be between 1 and 1.5 miles wide. And that area, I may say, was seen from a distance of 4,000 miles. That was the range of the camera of Mariner 9 when the picture was taken. And that's a very curious kind of landscape indeed, and geologically very interesting. And just in passing, we are very sorry not to have Peter Cattermole, the geologist, with us today, but unfortunately he was down with flu. Now, on Mars, we get grooves. You can call them clefts or riddles or what you like. And these, I think, are some of the most interesting things we see. You get them on the moon, and here's a picture of a moon groove. That, in fact, is in the crater Alphonsus, and that was taken from a ranger craft some time ago. And you can see that that so-called rill is very largely a crater chain, made up of small craters that are run together. Now, we found that we get the same kind of thing on Mars. And here's a fantastic one in the so-called Noctis Lacus. You can see there a large number of grooves, again 1 to 1.5 miles wide, and apparently their slopes of the inner walls are between 10 and 15 degrees. And if you look closely along their walls, you can see there indications of crater walls, which could mean, in fact, that these clefts, too, have been made up very largely of craters which are run together. But they're also genuine groove-like features. And looking at that picture, it's rather interesting, I think, to reflect that each of those grooves is on the same kind of scale as the Grand Canyon in the United States. So they're pretty big. And here's another one, which I've called the chandelier. Not a bad name for it, I think. And that's an intricate network of mighty canyons on what is obviously a volcanic tableland. Well, quite apart from those, we have things which look even stranger and quite significant. And just have a look at this one. And this is a 250-mile valley, and doesn't it look like a watercourse? And it's been compared with an Ario, one of those water-cut gullies that you so very often find in the southwestern United States. Well, I just don't know. Superficially, it does look very much like a watercourse. And so does this one, which I may say is even longer. That one's over 400 miles long. And there is some superficial resemblance there to the Hadley Rill on the moon, where the Apollo astronauts came down. But even though we think that Mars is a volcanic world, and volcanism is associated with water, a lot of people, including myself, are very wary about supposing that large quantities of surface water ever existed. But if those things weren't cut by water, well then what were they? And here's another one too. This is a great chasm in the area we call the Typhonius Lacus. And just look at those branching tributaries. They do, superficially, look very much like rivers, but in fact many of them are closed depressions. And I just wonder whether they were formed not by water, but by liquid lava or something of that nature. But certainly there's a great deal to be learned, and in trying to explain these things on Mars, geologically, we do definitely have a problem. Now, there's one more picture I want to show you, and this goes back to the Mare Serenum that I mentioned earlier, one of the famous dark areas. And this is one of the Mariner 9 pictures of it. And you can see there that it shows a series of parallel fissures, and those are pretty large and they're pretty wide apart. Now, do you remember Lowell and his double canals? Many years ago, Percival Lowell drew maps of Mars like that one. That's one of Lowell's charts of 1901. And he saw there straight lines, and some of these straight lines were doubled. Well, we now know that on Mars there are double fissures, and one of Lowell's double canals is pretty close to that area in the Mare Serenum where Mariner 9 has sent back this amazing photograph. And so I just wonder whether Lowell, with his big telescope, was a rather better observer than most people have thought, even though, of course, nobody nowadays believes in his fantastic ideas about intelligent Martians. And this does bring us on to the whole question of the existence, or non-existence, of Martian life. But if there is any life on Mars, then what form is it going to take? Well, I don't quite know, but I've got here some lichens, or lichens, whichever you call them. And these didn't come from Mars, they came from right here at Chelsea. And they're pretty lowly, as you can see. And it's been suggested that if there is any living thing on Mars at all, it's certainly not going to be more highly developed than that. Now, please don't misunderstand me. I am not suggesting that on Mars you're going to find Chelsea-type lichens. I am suggesting that any form of life on Mars is going to be no more highly developed than that. And our great problem now is to decide whether there's any life at all. Well, I personally don't believe that those large dark areas are due to vegetation. I think they are more likely to be due to shifting dust. But we can't be sure. And the one thing I am confident, the chances of our finding some form of lowly life on Mars are decidedly better now that we know Mars is an active world than they used to be only a few weeks ago when we believed Mars to be totally inert. And that, I think, is about as far as we can go. And not until 1976, when the American soft lander comes down there, shall we be able to decide once and for all whether there is or is not any living thing on Mars. The next Sky at Night but one, that's April, is going to be rather special because it marks our 15th anniversary. We began these monthly programs of ours way back in April 1957, which was, of course, was before the space age started, and that's quite a long time ago now. And so I thought that for the last program before the 15th anniversary, and that comes out on Monday, March the 27th, I'd try and answer a few of those questions which are always cropping up, and have done so all through our first 15 years. I do get a tremendous number of letters, 30 or 40 a day sometimes, and it is becoming very, very difficult to answer them all. I do my best, and I don't think so far I've left any unanswered, but I'm afraid just for the moment I've got to say that I really can't handle any more. On the other hand, I don't want to stop answering questions, and so our next program is going to be devoted to that. And if you have any special questions you want me to answer, well, will you write them down on a postcard and send them to me at this address? The Sky at Night, BBC Television Centre, London, West 12, 7RJ. I'll repeat that. The Sky at Night, BBC Television Centre, London, West 12, 7RJ. And I'll do my best. But on a postcard, please, to Television Centre, not to me at Chelsea. And please don't ask for a personal written reply, because much though I'd like to do that, I'm afraid I've only got one pair of typing fingers. And so, on March the 27th, question and answer. And for now, good night.